And so we're going to give a quick look at this have and need method of factoring polynomials, and we're going to be using it in the context of the box again, just so that you get an idea how it works. And so I'm asked to factor x cubed minus 4x squared minus 3x plus 18. I have learned using the factor theorem that f at negative 2 is equal to 0 because there are an impossible number of those to go through. And so I know that x plus 2 is a factor. And so x plus 2 goes up here. And fundamentally there is a quadratic, and we're going to do this just by the have and need method. And so I know that an 18 has to go down here. And I know that an x squared has to go up here. And so since there's an 18 here, I know that there's just has to be a 9 here. And so what we're going to do is we are going to play a little bit innocent, because we could in fact factor this quadratic probably using classical techniques, but instead we're going to say, oh my, I don't know what the coefficient is here, and so I'm going to put in an a and try and figure out what's going on for the a. And so this is x cubed, x squared, this one is a x squared, and this is 2ax, and this is 9x plus 18. I have that. Okay, this is where it all comes together. If I figure out what polynomial is in here, this is x cubed plus 2x squared plus ax squared plus 2ax plus 9x plus 18. Okay, I'm going to do a little bit of factoring here. Now, interestingly enough, this is enough for me to, just one of these is enough for me, based on the have and need method, to find out what a is. Because the coefficient of x squared is 2 plus a right here, but that must equal negative 4. And so I know that a must equal negative 6. I can test this out by looking here and investigating to see if my a value is right. So 2a plus 9, I need that to equal negative 3. I've calculated it here. Negative 12 plus 9 is negative 3. And so I know the factor over here, the x term has a coefficient of negative 6. And so I've figured out what my factor is. So that's the have and need method using the box.